All right, so 7.3, we are going backwards on what we did yesterday. Okay, yesterday we talked about the properties of parallelograms, and today we're using the converses of those. And yesterday, if you recall, the hypothesis for each theorem was the same. The hypothesis always said, if a quadrilateral is a parallelogram, then this. Well, converse, remember, we switch the hypothesis to conclusion. So today, all your conclusions are going to be the same. So all your conclusions today are going to say, then the quadrilateral is a parallelogram. So we are proving that we have parallelograms now. Okay, we're proving that we have parallelograms. Now we know we could prove that something's a parallelogram by using the definition. Right? If we see a quadrilateral that has two pairs of parallel sides, that's enough to say that it's a parallelogram, because that's the definition, that's what it is. But then we get into our four theorems here. First one matches up exactly with yesterday. This is the parallelogram opposite sides converse. This is saying if both pairs of opposite sides are congruent, then the quadrilateral is a parallelogram. And it has to be both pairs here. I want you to underline both pairs where you have it written down. Okay, it's not enough just to know one pair of opposite sides being congruent. You have to know both pairs are congruent. And this is knowing nothing else. This is not knowing anything is parallel, not knowing anything about the angles. This is simply knowing we have a quadrilateral where both opposite pairs of sides are congruent. Then we can say, yep, it's a parallelogram. The reason why we're doing these, guys, the reason why is because once we can prove that it's a parallelogram, then we can use all the stuff from yesterday. Right? So once we know, let's say we have this information, we say, all right, this is a parallelogram. Now we can use yesterday's stuff to say B is congruent to D, or A and D are supplementary, or stuff like that. But we have to know that it's a parallelogram first, and so that's what this is doing. It's getting us to that point. Again, straight converse of yesterday, opposite angles converse. So if both pairs, again, underline both pairs, please. If both pairs of opposite angles are congruent, then the quadrilateral is parallel. So same thing as the other one, just with angles now, both pairs have to be there. Both pairs have to be congruent for us to work. Not enough just to know one. All right, questions on those two? Say again? That's after the quiz. Yep, that's special parallelogram, 7.4. All right, so if we see something like this, all right, with the carnival ride here, looks like a dragon. One of these things that's going around in the circle. If we know the opposite sides are congruent, these are going to stay congruent. That means no matter where that ride goes, it's automatically a parallelogram. Because your opposite sides, both pairs of opposite sides are going to stay congruent no matter what. So that's always going to form that parallelogram. All right. So knowing what we know, right? We saw problems like this yesterday, but it was, hey, this is a parallelogram, solve for x. Same exact type of problem, just the wording's different. They're going to say, what values of x and y would make this a parallelogram? We've seen stuff like this before. So I want you to solve for x and for y here. I want you to get x and y. Careful on which one you have to do first. Check somebody, see if they got something.
It's like I saw. That one's big.
All right, what do we have for X? What do we have for X? Haley? 8, and what do we have for Y?
I didn't get 8.
Didn't get 8.
I didn't get 8. I got 10.
What'd you get?
And 17.
Yeah.
10?
10 for X.
So for X, we gotta set these two equal to each other. So we set that equal to X plus 9. Okay, we add the 1, we add the 1. Yep, and then subtract X, there we go. Yeah, X is 10, there you go, X is 10. And so Y would be
17.
17. There you go. You gotta solve the one with the two X's first, of course. You can't set up X equals to Y if you don't know either one. All right, good deal. Oh yeah. Now these two are not, well, this one is not a straight converse of yesterday. Okay, this is a new theorem here. Not a converse. So this one is opposite sides parallel and congruent theorem. So this is saying if we have one pair of opposite sides that's both congruent and parallel, that's enough to say the whole thing is a parallelogram. Okay, so one pair is both congruent and parallel. That's enough to say the whole thing's parallelogram. But it has to be the same pair of sides. Okay, it has to be the same two sides that are both congruent and parallel. The one that they're going to try to get you on is something like this, where we have one pair congruent and we have one pair parallel. Okay, that's not enough. That's not enough information to be able to say it's parallel. Okay, it has to be the same. The idea behind this is if we know those two are the same length and they're parallel, right? No matter where you move that to, if I connect the ends, it's always going to stay a parallelogram. Okay, it guarantees it to be a parallelogram. This is probably the one that people forget about the most, just because there's two pieces of information that we need rather than just opposite sides being congruent or opposite angles being congruent. One pair, both congruent and parallel. Okay. And then we get our last one. Our last one is a converse. Okay, it's a diagonals converse. This is saying if we know that the diagonals bisect each other, that's enough to say it's a parallelogram. So without knowing anything about the actual sides of the figure or the actual angles of the figure, if we know the diagonals bisect each other, so you got to know these two are congruent, these two are congruent, that's enough to say that's parallel. Okay, any questions on them? So remember, we're going to go back and forth between yesterday and today. Okay, we're gonna use these things from today to prove the figures parallelograms. And then once they are, we might have to use yesterday's stuff to prove specific angles congruent or something, right? So we're kind of adding on to those proofs that we did yesterday by adding a step before the start. So proving that it's a parallelogram first and then using the stuff from yesterday.
Why didn't we just do this first?
Because you don't learn the converse.
Yeah, you gotta use you learn the regular first before the converse. Yeah. Yep. Otherwise, it won't make sense if I just say this is the converse. All right. Good deal. So. Let's look at a few problems and then we're gonna be done. Okay, not a whole lot here. Same sort of idea here as the other one, but now we're looking at angles. We're gonna solve for x and for y. What values of x and y would make this a parallelogram? Okay, check somebody, see if you guys say anything.
32. Let's say the extra. It's 32.
All right, here we go. Weston, what'd you get?
32 for X, and then 29 for Y.
There you go, 32, 20. There you go. Good deal. Set those equal, right? Set them equal, solve. Got it. All right, tell the person next to you, which theorem are you using to prove these parallelograms? Tell them the names.
Yeah,
Yeah,
oh, the first one, yeah. Opposite sides. Are you opposite sides, converse, and opposite angles?
All right, good. Questions on that? Okay. I want you to recap those four with somebody. Please recap those four. All four of the theorems.
Opposite sides, opposite angles, opposite sides.
You got
Yeah.
There's four theorems.
This diagonal cross.
Because you got parallelogram opposite sides and its converse, and you got parallelogram.
But I'm just talking about the ones from today.
Yeah.
Just the ones from today.
Okay.
All right, so we had four theorems from today. Raise your hand, tell me one of them. What's one of them? Yeah.
Parallelogram opposite angles is when if both the pairs of opposite angles are congruent, then it's a parallelogram.
Perfect, good. So we got opposite angles. Weston?
Opposite sides parallel and congruent theorem, which is where if like two sides are both parallel and congruent to each other, then it's a parallelogram.
Perfect, good. Haley?
The parallelogram opposite side converse is if there's two pairs of sides that are congruent, then it's a parallelogram.
Great. So that's the third one. Okay, one more. One more. Kyle?
Parallelogram diagonals converse, which means if the diagonals bisect, then we know it's parallelogram.
There you go. Good. What's the fifth way that we could prove that something is a parallelogram? Other than those four. Bryce?
Would it be like the consecutive?
Nope. Zoe?
Would it be like the definition of a parallelogram?
Yeah, definition, right? So if we see that we have two pairs of parallel sides, that's enough as well. So really, we have 5 ways of proving that something is a parallelogram. Okay, the 4 theorems from today and the definition. Any questions about